Hello everyone, I am welcoming you all once again to this channel. So today I am going to make one video on this VESTA software. So where we will try to modify our MXene kind of structure. So here I have taken one this article, and like they have explored the possibilities of two-dimensional transition metal carbides as anode metal for sodium batteries. And here like they have done certain modification on this MXene kind of layer. So as you can see that this is a standard MXene, like two layer MXene. Like this is the metal ion, this is carbon, this is another layer, and these red colors are the oxygen for the on the termination part. Okay, so what they have done, you can see on the figure caption that they have like three different structures of oxygenated MXene, side and top views. This is a side view and this is a top view. And MXene with which FCC-type O termination, like on this is the FCC-type O termination or terminated MXene, and this is the HCP type. So here they have taken two different like as we know different void spaces are available where we can add the termination. So here is this is the oxygen atoms have taken the FCC coordinate, like the FCC part over here, and here they are arranged as HCP type. Okay, so on that basis like where the oxygen atom will go, so on that basis it is of two different kind. And here in the C like the figure 1C, they have mentioned the mixed kind of like one is with this HCP type, the upper part, and the lower part is with this FCC type. Okay, so we will try to design this kind of structure using a standard MXene structure. So I will open this on one side so that we can compare that whatever we will do today is same to this or not. Okay, so let's do it here. So here I have taken one MXene VASP file. So I am opening that using the VESTA software, and you can see that. So this is our one MXene structure, and if you will check this unit cell, you won't be able to notice the changes or the kind of structure. So I am making it to a super cell by using our transformation matrix, and I am transforming it to 3x3 layer. Yes, okay, then apply, then okay. Okay, now you can check that. So this is a kind of layer. This is of which type we will now see. Now you can compare this with this. As you can see that, yeah, one thing I will do here, that before going ahead, I will try to also add bonds between carbon and titanium so that our structure will look like exactly the same like whatever they have presented over there. Okay, now yeah, the bonds are now added. Now we will go and simply compare. Now you can see that this and this atom, yeah, now you see that this structure is nothing but this one, and they are exactly same. As you can see that this oxygen and this titanium both are lying on the same straight line as they have shown. And so that means whatever we usually took, those are there, this oxygen terminations like already present on this FCC kind of void or FCC lattice space. And so in that way, what will be the kind of structure postcard file that I am going to show you here. So here you see that the first coordinate is for carbon. So carbon is present on the middle layer, it is having only z axis, and then this O, you can see that these two O oxygen atoms, they are relative to this titanium, right? So only like they are having A and B value similar to the corresponding titanium atoms, and only the Z axis value is different, whatever we are seeing over here. Okay, so now one part of our study is clear, that this is very simple to do, but our main thing is to do this kind of structure. So where they will like where we will tell them this is a HCP kind of MXene or hexagonal closed pack kind of MXene. Okay, so for this what we will do, so that our oxygen atom, which were earlier with the in a straight line to titanium, will now be present in a straight line with carbon. Okay, so so what should we do? So थोड़ा सोचना पड़ेगा. लेट्स क्या किया जाए? Yeah, one thing we can do that. So if our this coordinate of the oxygen atoms, what we have seen in that postcard, that they are present relative to the titanium atoms. If we will displace these oxygen atoms in relation to the carbon, then only something can be happened. So this is what I am thinking right now. So let's go and do the same thing. So I am not going to do any modification to the earlier file, rather I am copying the same MXene to another. So this is HCP kind, so I am making the name as hcp.vasp. So same thing I have copied in a new file. So I am going to open this HCP one here. So what we will do, as we can see that these oxygens are relative to titanium, now we will make them relative to carbon. So what we will do, so what kind of modification we will do here? So we will change this A and B coordinates of the oxygen atoms to 0 0. Why 0 0? Because all the carbon atoms present over here are having A and B coordinates as 0 0. Okay, so I am changing all these numbers to 0 0, and for this oxygen also I will do the same thing. Okay, so I am editing all these using the Vim editor. You can use Vim editor, or you can even do like directly edit your text file, save it. Now I am going to open this HCP structure in our VESTA software. So I will first make one transformation matrix and unit cell. Let's do the transform. Let's check whether it has been done in the correct way or not. Yes, search. Okay, apply. Next, let's add certain bonds. Edit bonds. So here we will try to create new bonds between titanium and carbon, although they are little far, still we can do this and apply. Yeah, the bonds came, or we don't require that, it's okay. Let's see. So whatever the structure earlier we were visualizing over here was of this kind, right? And now the structure we have created is looking like same as it is, okay, as they have shown. So now I can also show you one bond between this one and this one. No, this one and carbon. Yeah, this oxygen and carbon. Yeah, so now you see that now these oxygens are lying in a straight line with carbon, and here they were lying with titanium, right? So they are in a straight line, and here this oxygen and carbon are in straight line. So that means we have created this structure just by replicating the oxygen coordinates similarly to the carbon coordinates, and our job is done. Now another thing is also here present over here, that is the C coordinate, like the C figure that they have given. and that is the mixed one. So for that, what should we do? So similarly, like first layer will be of this HCP type, and the lower layer is similar to the FCC type. So we will change one coordinate of this uh, structure. So which coordinate we need to change, that we will see first. So this is our which layer. So this is O1. Yeah, that means O1 will remain the same. That means O1 we need to change. Okay, let's go. So here I will do again the same thing. I will copy this, and now here I will rename this as to mixed dot VASP. Let's open this mixed one, and as we have seen that our O2 will be changed. So here I will only change the O2, because O2 will be of HCP type, and no, O1 will be of HCP type upper one, and O2 will remain as it is, like FCC type. So 00000. Yeah, let's save this. Let's open the mixed one using VESTA, and let's see that in the transform matrix, okay, let's transform this also. 3 by 3. Okay, yes. So this way it is coming, and let's go back and see on the A side. Yeah, now you can see that like we have modified similarly what they have given. Now these are in straight line, and this TI and oxygen, they are in straight line. Okay, so that means we are able to do. And also I will show you the top view also. So here you can see the top view for top view of all I will show in a single row. And yeah, so the top view for this one, first one, is you can check that this is exactly same as they have shown, and for the HCP one is also same whatever they have shown. Okay, and now for the mixed one, they have not shown the top view because it's a little bit crisscross kind is showing here, but what we can see from the side view, it is exactly the same. Okay, so this way we can do certain modification to get our desired structure. And after doing all these, I am not thinking that these works are much tedious. Rather, we need to think little bit, and we can implement our thought, so that we will get our accurate structure or exact structure. Okay, so thank you all, and bye bye.